Okay, today we're going to be looking at equations with variables on both sides, and we'll even look at some special cases called identity and no solution. So to start us off, we have a word problem comparing two putt-putt golf courses. So our pirate adventure, we'll use in red here, charges $5 entry fee and $2 for every game that you play. The Wild Wild West putt-putt charges $1 entry fee and $4 for every game that you play. So we want to know how many games of putt-putt would you need to play for the two courses to cost the same. So let's start writing some equations. So to represent my Pirate Adventure putt-putt, I know I'm charging $5 and it is going to cost $2 for every game you play. I'm going to call that my X. Now before I even get any further, I want to label that X as number of games. Okay, so I know that that needs to be the same as, which can be represented with an equal sign, my Wild Wild West putt-putt. So I charge $1 entry fee for that, plus $4 for every game that we will play. And my X is still going to be the same as the one that I defined. So up here, how I have X equals, that's going to be called a key. So it's where you tell me what your variables are representing. This is your equation. And then over here, running out of room, we can try and get our answer. So if I use that equation that I have, I'm going to subtract 1 on both sides, and then I'm going to come over there. So we will have 4 plus 2x equals 4x. Then I'm going to move my x's over, bring over that 2x. So I will be left with 4 is equal to 2x. Now I'll divide both sides by 2. And I will be left with x equals 2. So I have x equals 2, but what does that mean in terms of my question? Remember, it wants how many games of putt-putt would you need for them to cost the same? So we would need to play 2 games. Okay? All right, let's keep solving. So I always like to move my x's to the left since it is best practice to have them over there. So I'm going to move this x over here first. When I do that, I'll be left with 4x minus 2 equals 4. I'm going to add this 2 to both sides. Remember, I want x all alone, so I'm moving anything that's with x out of the way. On the left, I'm left with 4x, and on the right, I'm left with 6. Still have this 4 with my x, so I'm going to divide both sides by 4. And I will be left with x is equal to 6 over 4. Of course, we have to simplify, so we will have that x is equal to 3 over 2. Don't forget that x equals. Okay. Now we have kind of a bunch of things going on. I see I have some groups here and here, right? So I want to get rid of those first. So let's do some distributive property. So I'm going to multiply 4 times x to give me 4x, and 4 times negative 2 to give me negative 8. Still have this minus 2x here, equals, I'll switch some color. We have to do distributive property again. 5 times x is 5x, and then 5 times negative 3 will give us negative 15. Okay, so we took care of everything there. Now we can start combining. I see on my left, I have these two. So I'm going to do 4x minus 2x to give me a 2x. Still have that negative 8, and then I have 5x minus 15 here. Okay, so there's a few things we can do. We can either add this 8 over here, or we can, oh, wrong button. We can add the 15 over. There's a few things. So I'm going to bring over this 2x so that my x's stay positive. And I'm left with this. So again, I want x all alone. That 15 is in the way, so let's bring it over. On the left, I'm left with, oh, forgot my 1. There we go. I'm left with 7 equals 3x. Divide both sides by 3. Running out of room here. We'll just go over here. X is equal to 7 over 3. Improper fraction. I have my x equals, so we are all set. Okay, when we look at the next one, I see some more groups. I see this group here. This is grouped off with some parentheses, but I don't think we have to do anything with them. So let's start distributing in. If I do 3 times x, it gives me 3x. 3 times 2 gives me a positive 6. Next group. So I'd have this negative out here. That's really a negative 1. So I am going to distribute that negative 1 into each term. Oh, the 1 disappeared. So I'll have negative 2x. Negative 1 times negative 4 will give me a positive 4 equals. And then in my last group, I again have that negative, which is really a negative 1. So I'm going to multiply that into each term. So negative 1 times 4x gives me negative 4x. And negative 1 times 1 gives me a negative 1. Okay, so I got rid of some of my groups. On the left, I'm going to combine some like terms. I see I have a 3x and a negative 2x, so that will leave me with just 1x. And I see I have a positive 6 and a positive 4. So that gives me a positive 10 when everything else on the right is the same. Let's start moving things over. I'm going to bring this 4x over. So on the left, I will have 5x plus 10 is equal to negative 1. Let's bring over my negative 10. I will be left with 5x equals negative 11. Divide both sides by 5. Oh, we'll come back over here. So x is going to be equal to negative 11 over 5, and that is our final answer. We have the x equals, we have a improper fraction. We are good to go. All right, for this one, it looks like we have some groups going on. We have this group, and then we have this group over here, which also has this group inside. So I'm going to work with this one first, since it's inside of this bigger group here with these square brackets. So I'm going to just bring down this negative 4 and fill in everything that we can. So let's multiply that 2 times m, and then that 2 times negative 7, and that negative 5 is going to stay. Then I'm going to bring everything else down. Okay, I see still in this group that I can combine some things. So let's do that 2m minus 5m, so negative 3m minus 14. Still have that negative 4 out front. Okay. So even though these are square brackets here, it is still a grouping symbol, and I am still going to multiply this -4 in here using the distributive property. So if I do that, I'll wind up with a positive 12m and a positive 56 here, with my 10, and everything else is still the same. Oh. Okay, on my right I have this 10 and this 56 that I can combine. And this is still the same. Okay, so it looks like everything on the right is taken care of. Let's take care of this on the left. So let's multiply then that 5m and to the -6. Okay, now let's move some things over. I'm going to bring over this negative. I'm going to subtract 5m from both sides. And do that. We're left with a positive 7m. Now we can bring the 66 over. So we will be left with 72 over here. Oh, is equal to 7m. And then I don't have much room, but I'm going to divide both sides by 7. So we will have 72 over 7 is equal to m. And, oh, -72, sorry. That's going to be it. I am going to switch those because we always want our letter on the left. So in this case, we have an M, not an X anymore, but I do have it, and it is improper. Okay, let's see what else. We have, it's not letting me. Okay, these are partner activities, so feel free to pause the video and work with one of your partners or table mates. I'm going to start solving. So for A, let's bring over the 2x. We're left with x minus 5 equals 12. Add 5 to both sides, and we are left with x equals 17. All right, B, I see I have this group here, so let's multiply in the 2. When I do that, I'm left with 2x plus 8 plus x. I'm going to add these two together. I'm still solving for x, so let's bring over the 3x. These x's go away, so I'm left with 8 equals 8. All right, let's look at C. I have this group here. Let's multiply in the 2. When I do that, I'm left with 2x minus 2 plus x. Let's combine these. Okay, let's bring over the 3x. Again, these 3x's cancel out, so I'm left with 2 equals -2. All right, we will come back to B and C in a minute. We're going to be comparing these equations in Desmos. So if we were to type this part into one section and this part into another, we can see what that looks like. When we do that, this is the left, this was the right, right? It looked like this. We can clearly see that those two lines are meeting in this point. these two lines have one solution, right? When we solved it on the slide before, we wound up with x equals 17. That is one solution. B looked like this, right? And remember, we were simplifying and trying to solve, and we wound up with 8 equals 8. So what that means, and you can see it on Desmos, is that it's really just one line on top of another line. When that happens, we can say that there are infinitely many solutions. We can call it the identity. Okay, we can also use a symbol. This R, which means all real numbers. So what this means is that any value of x will make the equation true. No solution, so this is the one. It looked like this. And remember, I think we wound up with 2 equals -2. So clearly, just right here, we know that 2 is not equal to -2. And when I look at them on the Desmos, I can see that these two lines are not intersecting. So that's why there's no solution. There is nowhere that they are crossing. Okay, so what did we learn? One solution. What does it look like graphically? We will have two lines intersecting each other. And I'm going to add a little note. Algebraically, we will have x equals some number. Identity solutions, where the solution is any real numbers. What does this look like graphically? So it is either looks like one line, or it's really two lines on top of each other. Now there's a special word for when this happens, and that is coinciding. Okay, and I'm going to do my little note. Algebraically, when we're solving, that is going to look like, it could look like 0 equals 0. It could look like x equals x. It could look like 2x plus 1 equals 2x plus 1. The left and the right side of your equal sign are going to be the same. And then the last one, no solution. What does this look like graphically? I'm running out of room here. We are going to say that is two lines not touching or crossing. And my little note, algebraically, we're going to wind up with something that is not true. So we might wind up with 1 equals 2. X, nope, not an X, sorry. Maybe 3 equals 5. I don't know, something that's not true. Problems are just for practice. So let's see. I'm going to distribute in this negative. When I do that, I am left with x minus 4. Okay, let's keep going. I'm trying to solve for x. I went up with 8 minus x equals x. Let's add an x. You wind up with 8 is equal to 2x. Divide by 2. X equals 4. Now I don't want to just say that. I also want to add how many solutions there are. As you can see, it says x is equal to 4, so there's one solution. Next, let's see. So I'm doing this group, negative 3.6 times y is negative 3.6y, and negative 3.6 times negative 1 is positive 3.6. And then on the left, I have 3y plus 1. Okay, let's add over my 3.6y. I will have 6.6y plus 1 is equal to 3.6. Subtract 1 on both sides. And I'm left with 6.6y is equal to 2.6. Let's do divide by 6.6 on both sides. And since I'm working with decimals, I am going to leave my answer as a decimal. So I am going to get 0.39, and I'm just going to leave it at that. And again, I don't want just what the solution is, I want to say how many. There is 1. Okay, now we have a fraction. I'm going to combine these two on the right, and to do that I'm going to change this 2 over 1 to be a 4 over 2, so that I can do 4 over 2 minus 1 over 2. So I will be left with 3 over 2 over here. Okay, let's do some other things. Subtract 3x on both sides. So these go away. I'm left with 4 equals 3 over 2. That is not true. So there is no solution. We can say that. We can also use that symbol here. Either one of those are perfectly acceptable. Okay. 2x minus 1 and negative 1 plus 2x. So these look similar to me. I want to see. I'll restart them. I'm going to add 1. Oh, these go away. 2x equals 2x. I want to subtract 2x. 0 equals 0. So you can see pretty much the whole way through, these were equal. These are equal. They're the same. These are equal. So there are infinitely many solutions. Infinitely many solutions. Or identity. The solutions themselves are all real numbers, or that symbol. So this is my solution, and this is how many. Sorry, let's put the identity over here. Okay. Okay, next. Let's add x. I have 8 equals 2x minus 8, add 8. I have 16, divide both sides by 2, x equals 8. This is my solution, and there is only one, as you can see. Okay, let's do this. Let's multiply in that 4. When I do that, I'm doing 4 times 1/2, which is 4 over 2, which is just 2. So I am going to just write 2x here. When I do the same thing here, I'll be left with 2. Now I will have 2x take care of this, plus 1 is equal to 2x plus 1. Right here I can see this is the same thing as this. Both sides are the same. So I have all real numbers. We can use the symbol, or we can write identity. We don't need all 3, just 1, but any of those are okay. This is the solution. How many are there? Infinitely many. Solutions. Okay, I'm going to leave you guys to finish the rest.